In this tutorial, we're diving into Unreal Engine 5.6. You'll learn how to create reactive Niagara effects and bring them to life with MetaSounds, all in a blueprint. No plugins, no shortcuts, just pure Unreal Engine power. So let's make your effects look incredible and sound alive and implement them in gameplay. Let's begin. So we're sitting here in Unreal Engine 5.6. Now all we've done so far is create a new project, completely blank, no starter content, just blueprint, maximum quality, nothing crazy. So essentially what we want to do here first, because we are in a blank project, we don't have first person or third person templates sitting here with us. You could import one of those if you wanted to, just to get some little bits that I'll be adding in later. But if you already have a project set up for first person, third person, whatever you have, this should still work for any of those. First things we want to do though is let's just get some good project hygiene started by creating a few necessary folders. So we're going to add new folder. Let's call this first one audio. Next, we can do Control-Shift-N for November, make a new one. Let's add in blueprint, FX or VFX, and that should be all we need for this. So, where we go from here first, we're going to set up the Niagara effect first, and then we will continue from there. So, let's open our effects folder. And we're going to right click Niagara system, and we're going to create an empty Niagara system. Now for this, you don't need to enable any other Niagara plugins. You don't need fluid or anything like that. It's just the base Niagara stuff that comes already pre-enabled in 5.6. We're going to call this ns_plasma, ns standing for Niagara system, plasma being, well, our effect. Double click to open that up, and lovely, opens in the wrong window. So we'll quickly fix that now. If you didn't know this, is a nice little tip. You can go edit, editor preferences. Here you can change a bunch of stuff, but the one thing I usually do is the asset editor open location. Just change that to main window, or at least that's what I'm going to do. So anytime I open something for this tutorial, it's going to open here. Makes life a little bit easier for me and for you as well. So, first thing I'm going to actually do right now, we're at the Epic headquarters. It's a lovely HDRI, but I don't necessarily like using this just for when I'm doing Niagara stuff. I prefer to be able to basically see nothing. So, where we can go from here, we have this little preview scene. Then we can go down to preview scene settings. Over here on the right, we have environment, untick show environment. We change this environment to be completely dark. And this is what I usually always go for whenever I'm doing anything in Niagara. You can close this and keep it open, but close it. We're just left with our details panel. Now, what we need to do here, we're going to create our first emitter, and this is going to be the core of our plasma. So I'm going to right click, add middle emitter. This just gives us everything we need as a base, and we can go further from there. So you have your emitter state, initialize particle, particle state, and the sprite render. You'll notice we can't see anything here yet because we haven't actually given a spawn for our emitter, but that's okay. We're going to get to that really, really quickly. So for now, let's just pause this simulation so we can add in the things we need. Now, if you haven't used user parameters before, usually you might be used to seeing these parameters, but we're going to create some user parameters that we're going to be able to use, but then also access later when we do some blueprinting. So I'm going to click this little plus, and we're going to add a new user parameter to the system. So we're going to make new, and you have all these things here. So you can go through and click them, or if you know what you're after, you can just type it. So I know I want a integer or a int. So unlike blueprints variables, you don't just have a int, they give you the int32 when it comes to Niagara. So use the int32, we're going to call this burst count. Take a guess what that's going to be for. Then we're going to create, not edit hierarchy. We're going to click the add new user. I'm going to do a Boolean. This one will be do burst. Click that to true for now. Add in a float. This one will be called Q shift. And then we're going to add in one more float. This one will be called intensity. So we have all these things doing different bits and pieces. We have a burst count, whether or not we're going to do a burst, we're going to do a hue shift, and we're going to have some intensity going as well. So where we're going to start with this, firstly, we don't want to have this called minimal. So we should be able to right click this and rename it. And we're going to call this NE, so for Niagara emitter, because this is an emitter. Plasma core. Again, you really can name these however you want. We're just going to keep a consistent naming convention. And a lot of things that I name on here are based on the Unreal Engine style guide, which I will link in the tutorial as well. So first things first, what we want to do for this emitter. So as we can see here, just some basic stuff. We're not going to change too much of this, but we will change the calculate bounds mode to fixed. So the bounds are going to be fixed from the emitter's bounds. And from here, just going to leave all that as default. Perfect. So next step we want to do, we have our emitter update. We're going to change the lifecycle mode here. So one of the best things about Niagara, if you haven't used it or literally anything in Unreal Engine, hover over something, it's going to give you a pretty in-depth explanation or tooltip about what it's actually doing. So the lifecycle of this, we're going to change it to itself because we get some bits and pieces here. We do want the loop behavior to be infinite, but we want this loop duration to be based on our intensity. So the more intense it gets, because this will basically, as a float, go from 0 to 1. So when we start getting further and further into that, you'll see really what all of this is actually doing. So our loop duration is, we're going to click this little drop down here, and one of the other things about the tooltips, sometimes they just stay there for a little bit too long. But what we want to have here is a 1 minus float down here. And then we're given a float here. What we want to do now is we want to clamp the float. So we're going to clamp the float between a value, between a min and max value. And the float that we want to clamp, this is where we're going to get our first user parameter. It's going to be our intensity one. So you just type in the name of the parameter. It brings it up here and it says, hey, you're going to get user intensity. The minimum we're going to change to 0.1 and the maximum we're going to change to 0.9. So we're never going to be fully 0, never going to be fully 1. And we shall recalculate the duration each loop. So as you can read, that allows the emitter to recalculate a new loop duration for itself every time it loops. Do that. Again, we're not seeing anything because we aren't actually spawning anything. So let's do that now. Let's add in a spawn rate on the emitter update. And here, if we just change this to like 100, potentially increase that to 0.5. We won't see anything yet, but we will. It's coming. This is one of the fun things about doing Niagara. Sometimes you won't see something for a little bit, but you will eventually get there. So if you haven't used Niagara before, you will get there. And we all get there eventually. So our spawn rate here, and one of the things we do with this, we'll get lerps and random values, trying to make it look in a way more realistic as you can for magic in a way, or plasma. So for this spawn rate here, we're going to actually do a lerp float. So we're going to lerp this between A, which we'll do 25, and B, which will be 240. Again, you can just change these values. These are ones that I found worked really well. And our alpha is going to be a clamp. Because again, if you've never used a lerp or linear interpolation before, what it does, especially with this, we have A and B and alpha. So when alpha is 0, it chooses 100% of A. And when alpha is 1, it chooses 100% of B. So what we need to do here is clamp that value so that the minimum and maximum, or the 0 and 1, will be based on whatever this float is, which, you guessed it, is going to be intensity. Intensity is going to be used to control a lot of the information we have here. Figured out why it wasn't spawning. Didn't press play, guys, so make sure you're pressing play. Change the intensity to 0, 1. You can see already, if you change it to 0, it spawns very slowly. 1, you can see that light flicker on a little bit faster. So that's all we're getting so far. But we leave that as min and max. So that's nothing too crazy there. Now, if we look at this initialized particle, what we're going to do here with the lifetime, we're going to leave it as a direct set. But the lifetime, because we want this to be a little bit more random, we don't want the lifetime of every single particle to be 5 seconds. We're actually going to have this do a minimum and maximum, and we're going to choose a random range float. So as I mentioned before, we want things to be a little bit more realistic and have a little bit more, or have a little bit more of a dynamic existence for this. So random range float can do 0.4 to 1.2. So that's the length of time that these will actually be alive for. Now, one thing we will quickly do here, just so we can see a little bit of what's actually happening, if we go to our particle update, I'm just going to quickly add in a curl noise force. And already it says, hey, you have this. We need a dependency that doesn't exist right now. We can click fix issue, and it's going to create that for us. And we're just going to leave that sitting here for now. What else we need as well is a vector noise force. Can leave that there. Good, we do have our solve forces and velocity. And then lastly, a point force. There you go. Now we see some action, right? So we have these little bits and pieces. Can't really see too much of what's happening yet, but you know, if you increase the strength of the noise, you can see how much that affects it. So change it to 0, kind of just goes out. Make it 1,000. If you zoom out, so that curl force is kind of like it's essentially curling it. So no noise. We've changed that noise to like 100. You can see it's starting to do more. 1,000. Or we'll just take it to 10. So you can see it's trying to curl it around. You increase it something crazy, and you can see crazy things happen. But if we just leave these back to default for now, we can see it's just having a fun time. The vector, increase that, you can just kind of see it start going crazy with that, and that point noise force is basically it's existing from a point, and then it's shooting that, or shooting those particles rather, out from that point. So we'll just keep that there for now, and we can start to see what's happening. So you can see intensity is low, intensity is high. So that spawn rate is already being affected by it. Lower intensity, lower spawn rate, increase the intensity. And you can already see that starting to be affected by it. So one of the reasons why it is good to use user parameters as well, instead of me having to go, oh, let me just go to spawn rate and let me just change those numbers and do that again and change it again, I have a slider here. Makes life so much easier. I can change it to 700. It's still going to be clamped at 240 because we did a lerp for that. But if we jump back to initialize particle, what we're going to go to from here is with our lifetime, we've done that, our color mode, because essentially what we're doing with this plasma is when its intensity is 0, it's going to be like maybe like a calm blue, and as it slowly increases to 1 with that intensity, that's when it's going to become red and vibrant. That's like its full power. So we're going to actually control some of that with our color. So with our color here, we're actually going to do a select linear color from array. There we go. Because what we're going to do here is we want to have multiple colors. So we're going to do a interpolate. So it's going to sample or interpolate between a bunch of different elements. So you can have as many as you want here. I'm going to go with 5. My first one, going to go do this little, maybe like a teal-ish color. Second one, blue. And again, like I'm just slowly starting to bring it around closer and closer to be that. Let's make that angry. Full saturation red. There you go. So at the moment, we change this. It's still that teal color. But what we want to do here, we want to interpolate. So as we start to get close to 1, you can see here, that's affecting that. Now, we could just use intensity for this as well because it is going to be based on the exact same amount. But we're going to use hue shift, and this is just so we can have a bit of control over the variables that we have created. Essentially, you could leave this as intensity because it will, it interpolates the intensity of it going from not intense to super intense. So we can just leave intensity as is. And you know what? I think we will actually not even use hue shift. Hue shift, you're deleted. So in the original test I did hue shift, but after coming back to this, I don't actually think we need this. So we can just go from here. So the interpolation, it will interpolate between intensity. So even if intensity goes to 800, it's still just going to be red. It's not going to go past that. So everything else will be clamped. So if you want a larger range, you can add in 100 different array elements to get a finer tuning of the color change, but I don't really need to. This works. Now the sprite attributes, we want to have a differentiation, so they're not all going to be the exact same size. So let's look at the sprite size mode, and we're actually going to do a random uniform. So it's going to go between 5 and 15. Already a million times better. Like, look how much cooler that already looks by just adding in a size. We're getting a random size. You change between 1 and 50, and you're still going to get something cooler than just one single size. So it goes to show how powerful changing the smallest attribute can affect a effect. It's worth it. Whenever you're adding stuff like this, play around with your settings. You have these things down here that aren't being touched. We have rotation and UV mode. Again, I'm not really doing anything with that, so I'm not going to touch it. But if you have things that are going to be rotating, it could be worth looking into. If you have a custom material that you're going to be using, you could do things with that, and it could actually work really, really, really So from there, particle state, cool. Just make sure you kill them. If you turn that off, they exist forever. Now, if that's your intention, awesome. And it'll just stop when the simulation stops. But this can really affect your performance. So make sure you have that turned on or off, depending on how you actually want to go about doing that. So what we're going to do, we're going to look at our curl noise force. So we're actually going to lerp our strength again. Boy, who guessed that? And we're essentially going to do the exact same things we've been doing for all of these. We're going to do a lerp float. Let's lerp it between 10 and 30. That alpha is going to be a clamped float. You guessed it, intensity is going to control this. Minimum of 0 and 1. That noise frequency, however, let's boost that up quite dramatically. And right now, can't see anything too crazy happening. Like, even if we change this back to 50, nothing crazy is happening, but we'll start to see more and more and more with the more that we do. So let's look at our vector noise force, and we're going to multiply by a float, and A will be 200, and B is, you guessed it, clamping the float. So that float will be, oh, I'll click the arrow, intensity, between 0 and 1. 0, 1. 0, 1. Then, if we look at our point force, we're going to have a look at this, and force strength, we'll do a lerp. Let's do 10 and 15. Alpha, guess what you're being controlled with? Intensity. So again, clamp float, intensity 0 and 1. So we actually look at this. It's not really being affected too much. 1. So you can see it's just slightly being affected. Very small plasma. As you start to incorporate more energy into it, that's when you can see it's starting to become more wild and chaotic. So that's what's happening there. So they are kept a lot tighter. Now you could, if you wanted to, change this to 50 and 100. Again, you're just going to end up with more of a chaotic system, really. Now, one thing we can do here, and we can test to see how it starts to look in a level. What we're going to do, just in our content folder here, I'm going to create a new level, and actually let's do it from our file, new level, just so we can choose the basic. And let's go file, save current level as, save it here. We'll just call this demo. Now we're in our demo level. What we can do, I'm just going to do Control L, turn down that sun. Let's give it a nice sunset. And let's just drag our effect in. Because here we'll get to see how big it actually is as well. Press play. I can see it over here. So it's quite small. So the more you add into that, the bigger it will be affected. Well, going to leave that in there. So after a quick crash and one demo level later, I no longer have the effect in there. So let's just try that again without pressing play. Let's chuck that in there. Let's reopen it. Whew. It worked. That's good. Okay, I'm glad that survived. Where are we? Point force. Let's change this back to 10 and 15 that we had. Awesome. So the solve forces and velocity, again, it's one of those things. It was a dependency. We needed it to be able to run some of the simulations that are happening here. So next thing we want to do is scale sprite size. Because essentially what we're doing is right now it just exists and then it goes pop, blinks into nothingness. We don't want that to happen. We want it to kind of come into existence and fade out of existence. So with this little curve here, well, essentially what we can do this ramp up, ramp down. And I can see it's kind of got a bit more of like a pulsation effect. Now you can, drag this to exist a bit closer, really come to existence really fast, or fade out really quickly. But I just like having just the default. Let that sit nicely in there. And really, that's all we do for it. Don't do anything too crazy with the scale sprite size. But we do the same as well with the scale it's just scale color. There we go. Scale color. Scale color. We have this scale alpha. So this will help with that transition to going in and out of existence. So this will be a float from curve. This, we're going to do this one, this pulse out. So it just adds that little bit. Turn that off. Turn that on. It gives a little bit more pulsation to it. Up that to a 1. You can see there's kind of just like has that little wispy just whoosh out. So essentially that's that Mi espresso. No, that's that done for that part of the first emitter. So what we're going to do is now we're going to do something similar for our next one. So where we go from here next is what we want to do is create a new minimal emitter. Rename this. You can just press F2 on your keyboard. This will be the Niagara emitter, plasma sparks. So these are going to be little wispy sparks that kind of circle around our initial emitter here. So on emitter state, we are going to get a spawn burst instantaneous. We also want this emitter system again to be itself. It's going to be itself. And let's make sure that is set to infinite. Yeah, there we go. Infinite. We have those fixed bounds again, which are eluding me. Because I didn't click fixed. There we go. Fixed bounds. Keep that as is. Awesome. So next thing we want to do, emitter state, that loop duration right here. What we want to actually do with that is change that to, you guessed it, what we had before. So what you can actually do, you can copy that and we can actually paste it over here. Admittedly, it does do that. So let me just quickly, I can delete that emitter state, copy it, paste it over here. So I want that to be first. So you can copy and paste things because we're going to use the exact same information here. That is one good thing about having Niagara emitters. Certain things you can just copy and paste over. Just make sure you delete it first. We did get that error saying, whoa, it's freaking out. because if you've ever used Photoshop where you have layers, they go from top down, very similar to Niagara emitters. It works from a top-down basis, so just make sure you have some things like emitter state, initialized particle, particle state. They exist at the top. You kind of need it to be that way. But on this spawn burst instantaneous, the spawn count is actually going to be based off the burst count. Right now there's nothing. If I change this to 10, you'll see 10 little things existing there. So that will come in handy a bit more when it comes into our blueprint. And a bit later, again, this is how you can set it all up. You can then make it a lot more custom after this as well, depending on the needs that you actually have. So spawn probability, we're actually going to click that. And the spawn probability is actually going to be make custom float from bool. That boolean is actually going to be our do burst. So this will come into effect. So if I have that turned off, the probability of it spawning is 0. If I turn it on, the probability of it spawning is true, 100%. So this will come into effect when we get later. When it starts off to be very low intensity, you get a little burst here and there. The more intense it gets, the stronger those bursts will actually become. So that's what we're doing there. When we look at our initialized particle, we have this direct set. Our lifetime of these, we're just going to set to 1. It's just going to be nice and small, honestly. And what we can do with our... So you can copy pretty much anything. So we're actually going to copy our color mode, come into our initialized particle, color mode. We should just be able to paste it, and hey, we get the exact same information. Perfect. It's tied together. So like I said, some of the stuff you can copy paste. With this, we're copy pasting it because it is the exact same stuff that we want to include in it. It has the exact same colors, so it saves us having to do any other bits and remembering and jumping back and using the color picker. It just works. The sprite size, again, random uniform. We're going 2.5 and 5 for this. Now, one of the things we haven't set up yet is because we can't really see it yet. We have a sprite render. We're also going to add a ribbon render onto this as well. Now, you can't really see that ribbon render right now, but we will very shortly. So, what we're going to add into our particle update, let's add in some curl noise force. Again, we need to fix it, which will give us a solve forces and velocity. We're going to do a vector noise force. See, you're starting to see what's happening now. See, we're slowly getting there. You see what's happening slowly. So what we're going to do from here, we just had those two, so we can actually start to see what's happening. We have those other little bursts happening, and that depends on, no, we set that to 100. You can see it's just bursting those constantly. But just set it for 10 for now. Be nice and relaxing. So we have our particle state that exists. What we're going to do, let's add some drag onto this. So drag, much like what it is, I'm going to move it up to here because that's what I had it done originally. Our drag, you know, it's much like what drag is in real life. So applies drag directly to particle velocity and or rotational velocity, irrespective of mass. So the drag we're actually going to put on this, we're going to do a random range float. So we're actually just going to affect this randomly between both minimum and maximum. So 25 and 50. We're only evaluating on the spawn of it. So it's only going to happen on the spawn. I'm not going to worry anything about the rotation. They're not rotating. Isn't really needed. But we can look at the curl noise force. We're going to bump this up to something crazy like 5,000 and 10,000. So you can see it's going a bit more wild now. See? We want this to look wild, like it's uncontrolled magic or plasma. That's what we're trying to achieve here. Now, if we look at our vector noise force, we're going to actually do a multiply with this one. Multiply float. First one will be 20. And that second one will be a clamp float. We clamped with intensity with a 0, 1. So the more intense it gets, that vector noise will be affected by it. So that's why we're doing that. So it's slowly coming together. We're seeing it slowly build up and up and up. After our vector, we got our solve forces. That's perfectly fine. Let's do our scale sprite size and scale color. So we can actually do our scale sprite size here. Paste that in. Scale color. Paste it in as well. So it's being affected the exact same way, no matter what. So if we just change this burst count to 100, we can see it's really starting to do something. 0.5. Yeah, we can see it's going crazy. And then 1, it's like this massive energy. So we have those bursts. Now, even if we change this down to like 50, it's still a nice amount. 1, it's just constantly bursting and going off. Again, you can tweak this to your little heart's content. Go crazy with it. Do whatever you actually want to do. This is just a good way to get you started and seeing what's actually happening here with that. The one thing I did find that worked really well with this, with the sorting for the ribbon, doing it back to front. I don't know why, but I just feel it looks nice. It's very hard to see a difference. But it basically just kind of has it that the particle it's attached to is the top of it rather than it being the bottom. I don't know. It just seemed to work a whole lot better and look a whole lot better. But essentially that is the Niagara component done. And so now we can move on to the audio component in MetaSound. Alrighty. Now that we've done that, we can have a look in our demo as well. G on the keyboard to turn on the game mode. We can see it pulsing along there. So again, if I change this to be 1, saved it, you'd see that value there. But if I also clicked on it, I can see those parameters here, so I could also turn it down. I have 2 instances of this. I can have 1.5 and 1. So we can see the differences between the 3 extremes. Hardly anything, something, and then a lot. So let's pause that simulation there, and let's just delete those from our demo level, because we want to give all of our attention to our MetaSound. So we're going to go into audio, and we're going to create a new MetaSound. So right click, audio, MetaSound source. So you can call this as MS or MSS. And call this plasma as well. So when we have our MetaSound open, what we're going to do, we're actually going to have a few bits and pieces in here. So on our inputs here, actually let's make them when we get to them. It'll be a little bit nicer that way. So we won't really use this input here. So you can just kind of sit them together. The unfinished won't really exist as well. That's something that happens a lot in MetaSound, unless you're doing these one-off kind of bits here. Won't really exist. So we also have an out mono because we're not panning anything between two different ears. Both ears will receive this mono output. So it's just one audio being put into two different ears. So don't think about this as it's only going to go into one ear. It will actually go into both ears. So what we want to do first is let's start off with a sine wave. So anyone that has done math before will know what a sine wave is. It's a woo. And if you want, we can plug this straight into mono. Maybe a little bit loud, but you can see it. So we extend this open. That's a sine wave. Wiggle wobble sound like that. And that's set to frequency of 440. If we change it to 100, you can see that sine wave is longer. So that's what sine is doing. It creates that wave, and that's basically, if you ever see a guitar string or a harp string or any stringed instrument really, if you see it in slow-mo, it's just moving like that. The higher strings, more like that. Lower strings, super long waves. So there's your introduction to music theory right there. So that frequency is actually going to come out to a map range float. So it maps an input value in the given input range to the given output range. So one thing I really don't like, and it is kind of a nice thing to see, squiggly lines like that, highlight them, press Q, it will straighten them up for you. But the in range of 0, in range B, so in range A 0, in range B 1, out range will be 60, and we'll go to 220. We don't want a really high pitched sound, we want a low hum of energy basically controlling this. In is actually going to be controlled by intensity. So we can actually right click in, we can promote to graph input, and let's call this intensity. So this intensity goes from 0 to 1. Remember, that's a key thing we're working with. There's a float value of 0 to 1 that will control this. So we can play this, change the intensity, and you'll see what happens. So something quite nice is happening right there. Now what we're going to do, I'm actually going to disconnect this purple line. So Alt and left click that line, and that will get rid of it for you. I'm actually going to do it from audio, drag that off and do a plus. So it's going to be audio, add audio. So we're adding audio to audio. From this one here, we're going to do a noise. Now this noise, we're just going to keep it as pink. So if we plug this in, we'll get to hear something a little bit different to what we had before. Again, warning your ears. Let's change that down to 0. So just adds a little bit of hiss to it, makes it sound more electric, really. That's all that's doing. Now we're going to disconnect that output there as well, because we're going to have this audio plug into a state variable filter. Again, cue those to make them straight. So if I plug this in with the low pass filter, and if I plug it in with a high pass filter, can't hear anything. So that's just showing you it has different filters here. The low pass filter, essentially what it's doing, it is blocking high frequency signals. So that low pass filter is allowing those low frequencies to come through, where the high pass will block the low frequencies. Low pass blocks the high frequencies. So different programs will use different terms. A low pass can sometimes be referred to as like a high cut or something like that. Depends on the software you're using, will depend on the terminology being used. But we have this low pass filter at the moment. So that's what we're working with. Now, we're going to go from here, this cutoff frequency. So right now it's cutting off at 2000. We go to 220. If I set this at 60, sounds a little bit different. So I just change it back to 2000. You can see that difference. You can see the cutoff frequency actually going into effect there. So we're going to control that with a map range float. Again, similar to what we did up there. Intensity, I can just drag it and drop it. If I change this one, it will actually change that one as well, because that's really what we need. So this cutoff frequency here, 0, 1. Here we're actually going to do 800 to 8000. So let's play it. So essentially what that is doing, it's really affecting more of the noise, because that noise has a very harsh, high-pitched sound to it that's coming through. So what this is doing, it's actually cutting that off, but also giving us a nice flush with it. Starts low and hummy with that noise, but then as it increases in that cutoff frequency, we get a little bit more of it. Now, what we're going to do with our resonance is we're going to get some kind of like a chorus happening, again, based off our intensity. This is basically to kind of show the change in color. So the more intense the color becomes with our Niagara system, the chorus kind of effect is going to come in for this state variable filter. So what we're going to do is a LFO. It's a low frequency oscillator. That's what that stands for. So frequency, again, will be controlled by a map range float and a intensity. But this is actually being changed to 4 and 15. So a lot less daunting. The minimum value of this LFO is -1. The max value will actually be 5. And we'll see how this sounds. So you can hear that? So it's less of a chorus, more of a flanger almost a wah-wah pedal. Almost sounds like a record scratching a little bit. But that's just to give us a bit of variance in our audio, what's actually happening, and translating that information to the visuals and the resonance of our plasma that we have going on there. So essentially that's our first bit of information. Now what we're going to do with this output here, we're actually going to disconnect that, because what we want to have here for our low pass is a mono mixer. And so if you have 8 different sounds basically, or voices in this MetaSound, you can do that, but we're just going to have 2 that plugs into there. We don't have 3, we're just going to have 2, something super basic. Now, have that plugged there, all looking kind of neat. We will go back through and start to comment some of this as well, so I actually have a little bit of idea of what we're doing. So for our second sound, this is going to be basically the bursting effect, like the ch that we're going to get as those bursts are coming in. So if we start with a noise, keep a pink noise, I'm going to go and create a wave shaper. So it applies a nonlinear shaping to the audio input, straighten those up. The amount that we're actually going to be giving is, you guessed it, map range float. Plug that in, intensity is controlling that again, 0, 1, we'll change to 0.5 and 2. So when this starts to you actually start hearing it, we're getting just like a kind of like almost like lighting a lighter. That flint strike sound is essentially what we're aiming for here. So will actually go into a 1-pole high pass filter. So this way we're blocking out those lower frequencies. That cutoff frequency, you guessed it, map range float, intensity controlling it. This will be cutting 300, 800. So that's going to be cutting that bit off. This will then go into a multiply node. So multiply audio. Perfect, here we are. This is going to go into the ADSR envelope. So attack, delay, sustain, release. So that's the ADSR. Perfect, and we have that out envelope there. Now what we're going to have here is trigger attack. I'm going to right click that, and it's going to be a, oh, is it an input? Yeah, it is an input. So it's trigger attack. We're going to call this burst. So we will get to see as well what this is actually doing. Now the attack time, we're going to change that to 0. It's just going to happen instantly. The decay is going to be quite short as well. So that attack is how long it takes to come in or envelop the audio. The decay is how many times it's going to basically sustain the level in the envelope output. Sustain level, so sustain between 0 and 1. We're not going to sustain this at all. Let's just sustain at 0.1 actually. Release time, let's do 0.05, so it's going to release it quite quickly. So it's going to take 0.05 seconds to reach the envelope output. So it's going to happen really fast and go away really fast. We'll leave these curves at 1. But what we're going to do is now plug this into that out. Let's just change the gain of both of these to 0.5, just so it's not as loud as we're doing this. Now we can test it. Let's change these even less, 0.1. And that didn't actually do anything for that one. Okay, good. So as that's humming away, we have this little input here. That's what that burst is doing. So you can play around with this, the decay time of 0.5. That sustain level, let's just change to 1. That release time, let's change it to 0.5. If we leave it at default, sustain it for 2, why not? It's not really affecting it too much at all. Essentially, you can just leave it as that. There you go. So you can play with that a little bit. See how it sounds. So if we change that back to 1, probably want to have this spark happening quite loud. So let's try that. Sound warning. That's why it wasn't working before. Forgot about that. So with this, if I do test with this, it doesn't update as you're pressing play. So if we change this back to our 0.1 sustain level of 0, that release time of 0.05, now we get that. If we had that sustain level at 0.1, I actually do kind of like the sustain being a little bit there, so it takes a little bit for it to dissipate. So let's comment this out, C to comment. Gives initial plasma sound that changes on intensity. Ignore that bit here. Let's just move up that area. Whoa, okay, calm down. Don't like right clicking afterwards. Where did my, because I stole it. One thing about comments, if you hover it over something else, it will steal that information. So this needs to come back to here. That needs to come back over here. So, oh, Q, there we go. There we are, we have that. This will controls cut off. This basically is kind of like a flanger where it does like a it's the best way I can describe it, really. That mixes it. We don't need to explain what a mixer does or the output. All of this, basically, this controls the controls the length of the burst. This here controls sound of the burst. So you can play around with those if you wanted to get a different sounding burst, but I kind of like this, kind of like almost like a mix between a hi-hat and a snare that's happening. So that's all that MetaSound is doing. So I can compile that. And now this is where the real fun starts to happen. So let's do a quick save all. Now, if you have a template, first person, third person, whatever it is, you probably won't have to do this, but because I don't have a template, I'm just going to create a few little things just so it exists for me. So if you're doing a blank project like me, you will have to do this. So blueprint class, I'm just going to create a controller. So player, controller, VFX, or let's call it plasma. So it's the plasma player controller. Again, you could just use your first person, third person, top down, whatever you have if you're using a template or your own custom ones, whatever that is. Now I'm also going to create a new blueprint class of a game mode. So it is BP underscore, no, not BP, GM. Wow. GM plasma. Do another quick save all. Now we will also need some input mapping context and a input action. So I'm going to right click and we're going to go to input in input action. So IA underscore charge. Why not? That's pretty much all that we're doing. We're just charging up some information. It's going to be a digital bool. I'm not going to change anything in here whatsoever, actually. So just save that, close it. Now we need input again, but we need the input mapping context. So the IMC. And what should we call this? IMC, should we call it just plasma as well? Or let's do player. You guys probably already have a default. Let's add an underscore in that one there. In here, in that IMC, what we're going to do, new mapping, we only have one, so that's going to be our charge. And I'm actually going to put this on the left mouse button. So if you didn't know that, you can actually click that little thing there, press any key, or do any kind of thing on your keyboard and it will just work. You can also search for these. You can search for an any key as well if you just want to press any key. Any key also is affected by your mouse. So if you use any key and you have a click, it will still trigger the any key, but left mouse button for that. Now that that's set up, don't forget, if you haven't done it, you'll need to go to your project settings, your maps and modes, choose your correct game mode, and then selected game mode, we want our player controller to be our player controller plasma. What you can also do as well is just make sure in that GM plasma that we ensure that player controller class is there as well. Usually is if you set it in your project settings, but better to be safe than sorry. That should be everything. We have the game mode and the custom player controller. That is about it. Awesome. So now that's done. Quick save all. Now in our blueprints, let's create our plasma caster. So right click, blueprint class, actor, BP underscore plasma charger. And what did I call this? That's just plasma, and effect is plasma as well. So everything's plasma. Consistent naming conventions. That's what we like. This is BP plasma charger. So it's charging the plasma. If we crack this open in the viewport, essentially all we're going to have there, but we won't even see anyway, we're going to add our Niagara particle system component, call this NS plasma. The Niagara system asset, we only have one, it's our plasma. So you can see here that it is activated. You can see it doing something, which is good, but essentially we don't want to actually have it as auto activate. We want our click to activate that. That's one thing. And then let's add in our, it's just audio, isn't it? It comes in as an audio, and this will be MS plasma. So the MetaSound plasma in here. That's that MetaSound. Not changing anything with our volume multiplier or anything like that. It just exists for us. Jumping back over into our event graph on our event begin play. Again, because I don't have this enhanced import system set up in a player character or something like that, I'm just doing it in this plasma caster. If you have a player character already, you won't have to do this because it would already exist. You would have your mapping context already existing. This input action will just be added to that IMC. So I'm just doing this because I don't actually have that player character set up. So let's cast to player controller plasma. Make sure we cast to that. Q to straighten those up. Get player controller. Make sure we have the player controller here. We want to add mapping. Can't add that from here because here we need to get the enhanced input local player subsystem. Then we can add mapping context. So we're basically saying, hey, cast to the player controller. Again, if you have a template or you have already created a custom character, you probably already have this stuff in. Just need to make sure that you are choosing the IMC there. And sets the mapping context as I don't have a player character. Easy as pie. So this is where the fun stuff happens, and we also need to make sure our class defaults, we have auto receive input as player 0. Otherwise, we can do whatever we want. It's just not going to work. What we want to do here, this is where the fun stuff happens. So let's get rid of our overlap and tick. We want to get our enhanced IA fire or charge. So we get that first one here, that IA charge. And so we're going to have a few different things. Our trigger, so it's occurring after one or more processing ticks. That's going to go into a sequence. So to bring that up super quick like I did, I've just dragged this off and tap S for sequence. You can do that for a lot of different things. So let's start with this our elapsed seconds, this we're going to promote to a variable, and we're going to call it delta seconds. So we have our delta seconds up here, which our then 0 plugs into. From here, we need to go into a branch. And what we're doing here is we're actually going to promote this condition to a variable called isCharging. So we're checking if we're charging or not. If we're charging, cool, we want to do something. If we're not charging, we don't want to do anything. So essentially, that's what we're doing there. Now, what we need to do here is let's create some variables. Let's create intensity. Let's change that to be a float. And let's add in, we can just duplicate this, call it charge rate. And I think that's all we should need. So we have our intensity here. So if it's true, let's set our intensity. Now the intensity, again, we're going from 0 to 1. So let's clamp that float. So we're going to clamp the float of intensity. Now the value, we need to get some information. So we're doing an addition here. So it's, between 1 and 0, but we want to get the intensity, and then we want to add our charge rate. So our charge rate by default is probably going to be something super, super low. So let's try 0.001. Basically, you can change that to whatever you want. So the intensity is going to be added every single tick. So that's what that delta seconds is. So the faster the frame rate, the faster this will charge. Now you could change this to maybe triggered seconds or however you want to do this. For this scenario, we're just doing it based on delta seconds, which we'll probably get somewhere else through this. And if not, at least we're setting delta seconds that we can use later. But we'll have a browse there. Now what we can do here is just some, casual error tracking. Some print string. Let's plug that in. So this, I think if we just compile and save, just chuck this plasma charger in here. If I press play, so it's playing the audio, of course, because we're playing, but you can see that going up quite slowly. That's just based off the left click there. So that's exactly what we want. Now for this, we're going to need an extra one here. Let's just actually grab this, bump it up a little bit so we have some room, and then we'll grab all of this and bump it down. The then one, so what we need to get is our Niagara system, and we want to set Niagara variable by string float. So what we're going to do, we're going to set this Niagara variable using a string, and that string will be intensity. Now what you can do as well, you can jump back to here. We can go to rename it, Control C, jump back, make sure we paste that in, and then we're going to get our intensity. The intensity that we're building up here will control the intensity in that Niagara system. So we need to do this again. This time it will be our no, it won't be Niagara anymore. It won't be intensity because we need to be doing the burst count. So let's change that because that needs to be an int. So we can just get rid of this. So this needs to be set Niagara variable by string not float int. Again, we can make sure we have burst count not duplicated, renamed, Control C, that. Now I can't just plug that in like that. Like, I mean, I can, but what we can do is we can times this by, let's say, 200. And then we can truncate it. Basically, we're getting rid of we're turning this float into a integer, basically, without just going straight into this here. Oh, sorry, that's what it is doing when you plug it in like that. It's truncating it. So I showed you how to do it without just it doing it automatically. So we've done that. Now I need to do quite similar to the MetaSound. So this is just set float parameter. Quite similar to the Niagara system. Oh, if I can just grab this one execute pin, that would be great. Again, everything's kind of being done by the intensity. And again, intensity is what is controlling that. So that should be pretty easy. And then we have one more coming off this. We're going to a branch. So dragging this off and tapping B for branch. We have a condition. So that condition is if it's less than or equal to a value, that value is going to be intensity. So if intensity is less than or equal to 0.5, we're going to do something. And this is something you can play with and change and potentially even just do a completely different way. This is going to go into a delay. So again, D for delay. This, we're going to get a random float in range. So if it's below 0.5, intensity is below 0.5, we're going to go between 0 and 0.5. If it's false, go off into another delay. Again, we're going to get this exact same node. This will actually go from 0.2. So if it's less than or equal to 0.5, to this. Otherwise, it's going to go a lot faster. Then, what we're going to get from here is the MS plasma. We're going to execute the trigger parameter that we set up. So both of these can get plugged in, which is awesome. But the trigger we're going to get is called burst. Make sure I'm copying that, making sure it's 100% good. So we're getting that burst. So every single time we're holding it down, we're charging it. We're setting that intensity. It's counting up, counting up, counting up. And then these are their little... Essentially, that is what's going to be happening. So to do that, though, we need to actually activate our, plasma for our sound and our visuals. So essentially, oh yes, let's change this from being autoplay to be, there we go, activated. So auto activate. So our plasma, we want to activate it. I already had it plugged in, but that's the MetaSound. No. Activate. Perfect. Now I want this to play. So that'll go there. So when it's started, we're actually going to activate it. Double click a wire to make it a reroute node. So let's just make this a little bit neater. Start time at 0. And then we're going to set is charging to true. So when we start it, we're charging it. And then do all of this kind of stuff. It's going to be just working, is charging by default set to be false. Then what we want to do for both of those is more than likely deactivate. And we want to stop. And then set is charging to false. And that would be on the completed, I believe. Cancel, completed. Again, reroute node. So now, in theory, this should work. In theory, this should work. Again, a little bit messy. And no, I'm not talking about the soccer player. Yeah, so we can go through and comment all of that. But let's just have a test and see if it works. So we have our plasma in there. Let's jump in and see if it works. Again, headphone warning. Let's look around. Sweet, so that works exactly how I wanted to. So now that is fully charged though. So what happens at the very end? Well, let's just set our intensity to be 0. So at the very end, it will, whenever you're not charging it anymore, it's going to reset it. So there you have it. A nice little plasma charger. Now we'll go through and comment this out. You don't necessarily need that string there, but feel free to keep it there. Let's break this off into different sections a bit more. Increases the charge amount every tick. Affects the user params in NS and MetaSound to affect appropriate settings. Then this one checks intensity and creates burst based on values. This one here activates the MetaSound activates the Niagara system and MetaSound and sets, well, it's resets intensity. So there we go. So that's a nice little tutorial. Again, we're keeping everything in-house. We're not using audio files. We created that MetaSound from scratch. Again, play with it, experience MetaSound a little bit more, go more in depth, create different sounds, go for gold with that. Again, with our Niagara stuff, we've created something really cool here, but again, you get to control how that's actually being affected. So in here, how we're, getting our intensity, multiplying it, and that burst count. So if we go back to our Niagara system here, that burst count, that's being controlled here. That's set to 50, but in all reality, that's being set between 0 and 1 times 200. So as we get close to it, we go, cool, let's do 0.5 times 200. It then has a burst rate of 100. So we still affect that variable, but we're doing it in a way that we're getting this here rather than having that as a float. Because if we look at it, it's already just an integer. So rather than trying to do a conversion here, we just do a conversion in the blueprint itself. But there you go. You now have a cool looking system. So enjoy playing around with that. Thanks for watching and stay tuned for more.